It's 2026 and one of the most in-demand and highest paying tech jobs are actually AI engineers, and the numbers are growing at a crazy rate. And in an economy like this, when every single company wants AI engineers to keep up with their competition, there's currently a shortage of AI engineers to go around. So I'm gonna show you in this video how you can actually become a machine learning engineer or AI engineer in 2026. And just like any other job field, you're gonna wanna start off with the basics. And for this scenario, the first thing you're gonna wanna learn is Python. And if you're not familiar, Python's a very popular programming language used for like data science, AI engineering, machine learning, stuff like that. And it's very popular in the machine learning field. So this is probably one of the best places to start since it gives you exactly what you need to actually get started in the industry, and it's exactly what everyone in the industry uses. This is 30 Days of Python. It's a free GitHub repository that gives you a complete step-by-step guide to mastering the language completely from scratch. If you're a total beginner or you just want to sharpen your skills, it actually gives you bite-sized lessons that you can get started with. They tell you about syntax, data types, functions, loops, APIs, and a ton of other stuff. And once you're done with the basics, you're going to want to jump into libraries like NumPy and Pandas, since these are very common in the machine learning field, and they'll probably be what you're using on a day-to-day basis. And I don't want to leave you high and dry, so a good project that you can actually build to make sure that you understand NumPy and Pandas is a CSV analyzer. So what you're going to do is get a CSV and actually use NumPy and Pandas to read through it and then generate stats based on that. So this is actually getting you started in data manipulation, and then once you can do something like this, you're ready to move on to the next step. And the next thing that you're going to actually want to learn is the math behind machine learning. But wait, it's actually way easier than you think, and I've only added the important things that you need to get done in here so you're not wasting your time learning a bunch of random theories and equations that you don't need. And I also personally do not like math, so I made it really easy, and it boils down to 3 different things. First, you have linear algebra, then you have stats, and then you have probability. And the good thing is that you don't need to master it in the beginning. All you really need to know is the basic stuff, and you can move forward to the more fun AI stuff. And this is actually where things start to get more exciting. Learn the different algorithms, the different ways to train your models, how to build your first model. It's gonna get way more fun from here. And at this point, it's a lot of trying and testing and learning from your mistakes. So the one thing that I recommend for you to try out first is the Andrew Ng machine learning course. This is probably what everyone recommends to you since it's really comprehensive and gives you a good understanding of the different algorithms, the different learning methods, everything like that. But I will say, if you want to try something that's a little bit more hands-on and you get more opportunities to build different models, try different algorithms, code a little bit more, then I suggest the Google Machine Learning course. It's completely free and it's awesome. And at this stage, you'll actually know how to build your own basic models, use different algorithms, use different tools. You'll actually be a pretty decent engineer to start with. And the perfect way to actually test this out is by building a project. So the project that you'll be building is a housing price predictor using a data set from Kaggle. So once you're able to do this, you'll know that you'll have a good understanding of using models like linear regression, how to clean your data, how to estimate if your model's working or not, different types of frameworks, like if you're using TensorFlow or PyTorch, you'll understand all of this. So if you're able to build this project, you know that you're good to move on to the next step. So the next thing that you're gonna learn are some of the more common algorithms, and these are algorithms that are actually used across social media sites, Netflix, YouTube, a bunch of different sites, and these are the things that you'll actually see in the real world. And the algorithms that you're gonna wanna learn are things like decision trees, random forest, k-nearest neighbors, and clustering techniques like k-means. And the next thing that you're gonna wanna learn is something called feature engineering. And let's take the housing price predictor model as an example. And for that data set, you're gonna have different statistics like the year that the house was built, how many floors are in the house, the number of bedrooms, the number of bathrooms, stuff like that. And all of these are stats that'll actually help you determine the price of the house, but in some data sets, you may not have this. And the thing is that not all data sets are gonna have only helpful data. So some data sets are gonna have different stats, like if there's a gate around the house, if the grass is 1 inch or 2 inches high, stuff like that that don't really make sense. And your job is to then go ahead and determine what is actually useful to help you predict the price of the house and what is throwing off the model and giving you weird results. And this actually becomes a really important skill for machine learning engineers to know, because this will either make or break a model. And to learn these algorithms, the best thing that I recommend is using Sci Kit Learn Documentation. It's very well documented and gives you code snippets of like how to do it and very good tutorials. And what I'd suggest to learn feature engineering is Kaggle's feature engineering course. It's completely free and it only takes about 5 hours, has a lot of good content in there. And another good project to make sure that you actually understand these concepts would be a movie recommendation system. So building something similar to what Netflix has to make sure that you understand how collaborative filtering works. And collaborative filtering is a technique used based on the k-nearest neighbors algorithm, which is what social media sites use, Netflix, Spotify, and it basically determines how likely you are to like a different song, video, movie based on the fact of whether others like it. And this is the type of algorithm that actually puts people into groups, and based on whether someone actually likes something, it'll recommend it to the other people in the group. And now we'll probably move on to one of the most exciting parts and a subset of machine learning, which is called deep learning. So this is where you learn your fun stuff like neural networks and different image classifiers and computer vision, fun stuff like that. So first you're going to want to start off with neural network fundamentals. You can start with something like PyTorch or TensorFlow, but what I'd recommend is actually starting off with PyTorch, since it's a little bit more user-friendly and very easy for beginners to start off with. And you can actually use FastAI's deep learning course, and this is actually a really good course that has many different tutorials on how to do different things in deep learning. So it'll teach you like backpropagation, neural networks, forward passing, stuff like that. And he has a ton of lessons that shows you how to go from a deep learning beginner to a master. And the good thing is that some of these tutorials also have a full YouTube video attached, which shows you exactly how we built the project from beginning to the end. And this is actually where the projects get way more exciting. So the first thing that you're going to want to build is something called the MNIST digit classifier. So you're basically using a data set of handwritten digits and you're detecting the numbers. This is basically the hello world for neural networks, but once you're able to complete this project, you'll know that you'll have a good understanding of how neural networks work, backpropagation, optimizers, activation functions, convolution layers, and a bunch of other stuff. And if you want to step it up a level, you can actually create something called an image classifier, where you have a model actually take in images and determine what it's seeing. This is actually a really good project to put in your portfolio, and it looks great to recruiters. There's a ton of good resources out there, so I'll add one in the description so you can check it out. And at this point, you have all the basics down, so you can actually get started in advanced deep learning. And this is actually where you learn some of the more complex topics. So you have things like RNNs, LSTMs, sequences, and model optimizations. And at this point, you can actually check out Hugging Face's course on NLP. It's completely free and gives you a good understanding of how you can actually build NLP applications. And at this point, you can actually build your own sentiment analysis tool using NLP on product reviews or Twitter threads or different text messages to determine if it's positive, negative, neutral. And the good thing is that this is actually a common software that companies really need. And there's not a lot of tools that actually help companies build these based on their own product reviews or based on their own social media sites. So they're likely going to need someone to build it in-house, and that's where you come in. And if you're interested in going down the LLM route, you can actually build your own text generator that can write in a similar style as an author. And at this point, most courses and videos stop right here and tell you that this is all that you need, but they're forgetting a key part. Because building a model is one thing, but actually deploying to production is something completely different. And the best way that I've found so far to actually learn this is the MLOps Zoom Camp. It's actually a free GitHub that has a ton of YouTube videos and tutorials showing exactly the process of building a model to actually deploying it and testing it. It'll teach you how to deploy models using things like Flask and Fast API. It'll also teach you how to use something called Docker, which will help you containerize your applications and then push those to platforms like AWS or Google Cloud, which will actually let you run your models. They also teach you things like testing and model monitoring, so your model doesn't break after you push it to production. So an easy way to know if you understand this is by building a simple API for the image classifier project and then pushing that to Heroku or AWS, and then building a very simple front end that users can actually use. And bonus points if you can actually containerize your model with a platform like Docker, since this is basically what every company does in production. And this is practically it, but to make sure that you actually understand everything, you're going to want to start building with real data set. And you're going to actually want to focus on real projects that solve real problems, because this is exactly what's going to get you hired. So some of the really insane portfolio projects I've seen so far are medical imaging systems that can actually detect diseases. You have chatbots that can ultra focus on problems and solve very specific use cases. And then you have things like recommendation engines that work for different content systems or different products. But if you actually follow this roadmap and build these projects, you'll be ahead of 99% of people that are starting out and just scrambling trying to figure out what they should do. And if you found this video useful, make sure to subscribe for more videos like this and drop a comment letting me know what you want to see for the next video. So go out there and land that machine learning job, and I'll catch you in the next one.